Hi everybody, it's it's Leanne. I almost said Miss Lorenz. That's who I am here at school. And I am just going to go through the homework for section 5. And there are only 3, but they're, pretty big doozies. This gets into our last final push of proportional reasoning and just looking at whether proportions are appropriate to use, proportional relationships versus relationships that are inversely proportional. So hopefully you had some success with these homework problems and you're ready to just reflect on them. All right, here we go. Number 1, we are looking at stuffing flyers into envelopes, and we have 6 people that can stuff flyers into 500 envelopes in 5 minutes. And we're going to assume all the people work at a steady rate. So the relationship between the number of people stuffing envelopes and the number of minutes it takes to stuff flyers into 500 envelopes is what type of relationship, and how can you tell? And we're going to use a table and a graph to help us explain that question. And we also had to include an entry for 5 people. So you can see that in the table at the end. But this is an inversely proportional relationship. And I know that because when we divide the number of people by a number, like 2 to get 3 people, we multiply the number of minutes by the same quantity. And so if we divide by one number, then we can multiply that number to get the other quantity. And so it's inversely proportional. And then if we graph it, we get this situation. You can see that our line isn't proportional like this direction per se, like we're going to see in another problem, but rather it is inversely proportional. So I just included 3 of the dots on the graph here that come right from the table, but you can see that as the number of people increases, the number of minutes decrease. So hopefully that also makes sense to you. Proportional, as the number of minutes as the number of people increases, so does the number of minutes increase. That's not happening. As the number of people increases, the number of minutes decrease. That's why it's inversely proportional. All right, and then in B, this example, let's go back to it. In B, the relationship between the number of people and stuffing envelopes and the number of envelopes they can stuff in 5 minutes is what type of relationship, and how can we tell? And so this time, because we're looking at the problem a little differently, this is a direct proportional relationship because, as you can see, as our number of people increases, so does the number of envelopes. So let's just look right here. As our number of people increases, so does our number of envelopes. In fact, when we go from 6 to 12, we're multiplying by 2, and the same thing's happening when we go from our envelopes 500 to 1,000. So it's a direct proportional relationship. Whenever you divide one quantity by a number and then you divide the other quantity by the same number, you get this proportional relationship. And the same goes for multiplication. For example, if you double the number of people, then you also double the number of envelopes too. Then we end up with this lovely straight line, this nice example of a linear relationship. All right, let's take a look at number 3. This is the sewing problem. If 10 workers take 8 hours to sew a store's order of pants, then how long would 15 workers take to sew the store's order of pants, assuming all workers work at the same steady rate? And then we have to look at this proportion and ask ourselves if it's appropriate for this problem. Hopefully you did number 1 first, and after doing number 1, you thought to yourself, wait a minute, that's not going to work because this is actually inversely proportional. The more people that are sewing, the less time it takes, not more time. So the problem does not apply, or the proportion does not apply, because the relationship between the number of workers and the number of hours to sew, like I said, is inversely proportional. It's not proportional. This is because n times as many workers, so if it's 2 times as many workers, for example, it'll take half times as long, half as long, right? So 1 over n times as long. If there's 3 times as many workers, it'll take a third times as long to sew the store's order of pants because they can split the work among them. So in B, we're asked to consider how to reason about the multiplication and division to solve the sewing problem. And so this is like a classic problem, right? Here's how we could reason through this. We could reason that we will need a total of 80 workers, so 8 times 10 workers, worker hours. And with 15 workers, then the order would be finished in 80 divided by 15, which is 5 1/3 hours, which is 5 hours and 20 minutes. All right, and then one more that's just like this as well is the ditches problem. If 6 people take 3 days to dig 8 ditches, then how long would it take 4 people to dig 10 ditches? We're going to assume all the ditches are the same size and that it takes equally long to dig and that all the people work at the same exact steady rate. That's how these problems end up working for us. So we're going to explain how to reason with multiplication and division in this problem. All right, here we go. So if it takes 6 people 3 days to dig 8 ditches, then this is a total of 6 times 3 or 18 people days to dig 8 ditches. So that's what it's going to take. It's going to take 18 people days to dig 8 ditches. So it should take one person 18 days to dig those 8 ditches. And then one person can dig 8 18ths because you're just going to divide 8 by 18. So one person can then dig 4/9 of a ditch every day. And so then to figure out how many 4 people could do, we're going to do 4 times 4/9, right? So 4 people could then dig 4 times 4/9 or 16/9 ditches every day. And so to figure out the number of days, then we're going to divide 10 by that number. So 10 divided by 16/9 is 10 times 9/16, which is 45/8, which is the same as 5 5/8 days. So I'm hoping that that's what you got too in that answer. These are not the only ways that you could do it. You could have drawn some pictures to help you reason through that, but I hope that helped, and thanks for listening.